Edexcel Core Pure, Calculus 2, Improper Integrals. Integrals with infinite limits, the divergent case. Here we'd like to integrate 1 over x between 2 and infinity. We can see from the graph that 1 over x has values which are decreasing, but it's not absolutely clear that if we look at the area from 2 all the way to infinity, whether the area would converge on a value or not. So in this example, we'd like to integrate 1 over x between 2 and infinity. In order to do that, I'm going to integrate 1 over x from 2 to a and consider what happens to the limit as a tends to infinity. So we're looking for the limit as a tends to infinity. If we integrate 1 over x, we get ln the modulus of x between 2 and a. And if I now sub in the top and the bottom limits, we get ln a minus ln 2. And we know that as a tends to infinity, the ln of a will also tend to infinity because the natural logarithm is not convergent as a tends to infinity, and therefore we say that this integral will be divergent. So the integral is divergent. It is not defined in the limit and therefore has no numerical value. We're now going to revisit the GeoGebra file to just look at the integral of 1 over x squared from 2 to infinity and the integral of 1 over x from 2 to infinity. So if first we look at the area bounded by 1 over x from 2 to infinity, so I'm going to let the top limit b get bigger and bigger. So although the values of 1 over x are getting smaller, this area is going to get bigger and bigger as we get closer to infinity, as the limit gets closer to infinity, and is divergent. If we now look at the area bounded by 1 over x squared from 2 to infinity, again the values of 1 over x squared are getting smaller as x gets bigger, but more significantly, as this top limit b gets bigger, the area converges and gets closer and closer to being a half. In other words, the area is convergent on 1/2. So the graphs of these two functions look similar, yet one is convergent and the other one is divergent. It is very difficult to determine this until you look at what happens in the top limit. So the process is to replace the top limit with a instead of infinity, and then to see what happens in the limit as this variable a gets closer and closer to the required value. In the next session, we're going to be looking at integrals with the function undefined at a limit.